Hi, this class we are going to discuss about oxidation of alcohols. I will teach you a very easy trick to understand oxidation of alcohol. During oxidation, we know very well addition of oxygen takes place as well as removal of hydrogen and another definition loss of electron. Out of these three in organic chemistry, usually we will use oxygen or hydrogen. We need one strong oxidizing agent in order to oxidize any compound. Let us take sodium dichromate or potassium dichromate, which is present in acid medium. So acidified Na2Cr2O7 or acidified K2Cr2O7 is a very important oxidizing agent. It is a powerful oxidizing agent. It oxidizes many compounds. Now let's see the first one, that is a primary alcohol. I have a trick. What is the trick? We can use this anywhere else in organic chemistry. Whenever you oxidize a primary alcohol, it becomes aldehyde. That aldehyde again becomes acid. You must remember this formula. Whenever primary alcohol undergoes oxidation, it gives aldehyde. Aldehyde further oxidation gives acid. We know the formula for aldehyde, formula for acid. And one more important point you have to note it. The number of carbon present in primary alcohol is repeated again in aldehyde as well as in acid. So that is why I have written here, if C is equal to X times, that is number of carbon X times in primary alcohol. In aldehyde also we will get the same number of carbon. In acid also we will get same number of carbon. Let's see one example to understand oxidation of a primary alcohol. You look at this ethyl alcohol, which is an example for a primary alcohol because the OH is directly attached with one carbon. That carbon is directly linked with one alkyl group or one carbon. So whenever the OH carbon is attached with one carbon unit, this carbon is primary carbon. This alcohol is primary alcohol. Name of the alcohol, ethyl alcohol, otherwise ethanol. It has two carbon. So eth, root word, and ends with A and E. Instead of last letter E, we will introduce OL for alcohol, OH. So during this oxidation, I am going to remove this two hydrogen and one oxygen. We will get water. So water is eliminated. Remaining, we have CH3, CHO. In between carbon and oxygen, we have to introduce double bond. It is a very easy trick. Don't worry about the mechanism. That is entirely different. Further oxidation of this aldehyde, which gives acid. Introduce one oxygen in between carbon and hydrogen, we will get acetic acid. So this is aldehyde. Name of the aldehyde is acetaldehyde. IUPAC name, it has two carbon. So write down root word eth, A and E, last letter E, we have to replace by using Al, ethanol. And further oxidation gives acetic acid. IUPAC name, ethanoic acid, because acids ends with OIC. Now let us talk about secondary alcohol. For secondary alcohol, what is the trick? You have to remember this anytime. Secondary alcohol during oxidation gives ketone, C double bond O. On further oxidation, which gives acid. And very important information, the number of carbon present in secondary alcohol is repeated in ketone, but in acid it is reduced. For example, if you take 5 carbon here also you will get a 5 carbon, ketone with 5 carbon, but in acid we will get 5 minus 1, that is a 4 carbon. Let's see one example to understand. Let us take secondary alcohol CH3, C, CH3, H, OH. This is secondary alcohol. The reason the OH group is attached with one carbon, that carbon is linked with two alkyl group. So this carbon is known as secondary carbon. This alcohol is secondary alcohol. So name of the alcohol, propane 2-ol. It has OH group at the second carbon. We have to give numbering from 1, 2, 3. So this is a linear chain, long chain. At the second carbon, OH is present. So propane 2-ol. It undergoes oxidation. Take this 2 hydrogen and one oxygen, we will get water, and introduce a double bond between carbon oxygen, CH3, C double bond O, bond CH3. This is propanone. It has 3 carbon, so prop, last E is replaced by ONE. On further oxidation, it becomes acid, but one carbon is reduced, so it becomes acetic acid. Let us move to tertiary alcohol. See the formula, memorize the formula. Tertiary alcohol undergoes oxidation, which gives olefin or double bond compounds, carbon-carbon double bond compounds. We will call it alkene. On further oxidation, this alkene becomes ketone and acid. That ketone again undergoes oxidation to give acid. Let's see the example to understand better. Here, the number of carbon, let us take 4 carbon present in tertiary alcohol. It becomes 4 carbon in alkene also. Further oxidation, it becomes 3 carbon plus 1 carbon. That is, ketone has 3 carbon, acid has 1 carbon. The further oxidation of this ketone gives acid, which has again 1 carbon reduced. That is a 2 carbon. Let's see one example to understand better. CH3, CH3, CH3. This is CH3. I have written CH2H. Now I am going to remove water molecule. Instead of 2 hydrogen, I am going to remove water molecule OH from here. That is OH minus hydrogen from here. We will get water. So water is eliminated. These 2 electron moves inside. We will get double bond between carbon and CH2. CH3, CH3, double bond CH2. In the next step only it undergoes oxidation, which produce ketone and acid. This ketone again undergoes oxidation, gives acid. Now you may be noticed here we have 1, 2, 3, 4 carbon. So 4 carbon becomes 4 carbon alkene, and ketone has 3 carbon plus 1 carbon acid. This 3 carbon ketone undergoes oxidation to give acid containing 2 carbon. I hope you understand. If you like, please share it, subscribe the channel. Thank you for watching.